Ladies and gentlemen, welcome to section 2 of chapter 1. And you read the essential question, how do you determine if angles or segments are what we call congruent? Now, real quick, when we talk about segments, guys, let me pull this up. When we talk about segments like this, you see this segment, Pennsylvania, the segment from P to A. Remember what segments are: set of points with two definite endpoints, an infinite set of points with two definite endpoints. According to this particular measurement, it is 10 centimeters. Now, how do you measure segments? Very simply. You can use a ruler, you can use a yardstick, a meter stick. You can do it in terms of miles. Actually, you know what? Let me pull this picture over. Here you go as an example. So if I drew a particular segment that went from this particular point right there on the football field, that went straight over here to the 40-yard line, that's a segment that's not 10 centimeters, it's actually 10 yards. So you could use yardsticks to measure segments. All very simple. In fact, I did this. If you go to Google Maps and MapQuest from 500 South Broad Street, where we are here at Mechanicsburg High School, and you MapQuest it to the front doors of the Capitol in Harrisburg, it's almost exactly 10 miles. Now keep in mind, that's not a straight shot, so it's not a segment. But you can measure segments with any of those particular things. Why am I saying all this? Because of the following thing. Whenever you measure angles, ladies and gentlemen, angles are measured not from a ruler, not from a yard, not from centimeters, miles, inches, decimeters, kilometers, not like that. They're measured in one unit and one unit only, and it's called degrees. Now, how do you measure any type of an angle? Well, here's what you do. You must use this thing called a protractor. And just a little snapshot from how this works. When you use a protractor, this point right here where the 90-degree line and the 180-degree line where they intersect, that point right there, that's where the vertex of the angle goes. You don't put the actual protractor over here on this point and say, hey, how big is the angle? You don't put it up here. You don't put it anywhere around. You just put it right back where it belongs on the vertex. And you make sure one of the angles goes through either the 0 or the 180. Whether it's on this side or in this side, doesn't matter. Now, I'm saying all this because when we talk about degrees, degrees is nothing more than this. When you talk about an angle, I'll get rid of this picture for now. When you talk about an angle like this, an angle in terms of degrees tells you nothing more than this, guys. It tells you how much turning this point C is doing from point T. So it's asking you, or it's going to tell you in degrees, how far did I actually turn from there to there? That's the measure of the angle, the amount of degrees that it turned. Now, if I put a snapshot, or if I go back to the snapshot and I put the picture on top of here, you're going to see that the measure of this angle is exactly 40 degrees because here's 0 and it turned the whole way up here to 40. Now some of you might be saying, wait a minute, what's 140 there for? Remember, here's where you start, so therefore you have to count 0 is the starting point because this side of the angle goes through that 0 right there. That's where you start counting. So it's 10, it's 20, it's 30, it's 40 degrees that thing actually turned. Now, I'm showing you all this because a very quick little recap. When you classify angles in terms of their degrees or in terms of their measure, in terms of their size, there's really only 4 categories. And here's how they work. So if you have an angle like this that is somewhere in this range, actually hold on, let me change colors if I can. So if you have an angle that is somewhere between 0 and 90, but not including 90, that has a special name. And here's what it is. So if I make it 30, if I make it 70, if I make it 80, if I make it 88 or 89 or even 89.999999, that has a special classification if it's somewhere between 0 and 90, but not including 0 and not including 90. That, boom, is called an acute angle. So I'd write that down in my notes. An acute angle is an angle that's between 0 and 90. Simple as that. Now, what happens if I take this particular angle and I move it right over here just a little more, like that, and make it exactly 90 degrees? Well, if an angle is exactly 90 degrees, well then, ladies and gentlemen, that has a special name. It is called You are right. A right angle. So exactly 90 is right angle. 0 to 90, but not including 90, is an acute angle. What happens if we extend this guy over here like this and make it 140 degrees? Oh boy, 140. It's more than 90, and it's less than 180. The name for that is obtuse. You got it. So here's obtuse. So an angle that's bigger than 90, not including 90, and less than 180, not including 180. So like 179.999999999. That's still classified as an obtuse angle. Now what happens if I take this angle and I pull it down here, that it reaches exactly 180 degrees? What then is that? That, ladies and gentlemen, is a straight angle. A straight angle is exactly 180 degrees. So there is a fifth one that you might have talked about in middle school, and it's called a reflex angle. A reflex angle is an angle that's actually more than, if you will, 180 degrees. And you can certainly have that. You can have an angle that's 270 degrees. You can have an angle that's 540 degrees. You can actually have negative degree angles. You can have negative 72 as an angle. You can have negative 45. We don't talk about those in this class. We'll do that in trig and algebra 2 and beyond. But these are the four main ones that you're going to need to worry about. And in fact, this one right here, a right angle, a straight angle in that hierarchy. Right angle is the first one that's going to be the most important. Straight angle is the second, really. And then acute and obtuse are kind of equally important. So it's right's the most important, straight's the next, and then acute, obtuse. So there's your four classifications of angles. So what then does it mean when we have these angles or segments congruent? What does congruent mean? Crazy question. Well, here's what congruent means. It is this. We'll do segments first. By definition, and yes, this should go in your notes, congruent segments are segments that have the same exact length. So if I drew a segment like such, and I labeled this as A, and this over here is B, and I said, hey, that segment right there happens to be 5 inches, or 5 miles, or 5 centimeters, whatever, it doesn't matter. And then I have another one over here that is CD, that particular segment. And I happen to measure that with the same ruler or same yardstick or whatever, and it comes out to be exactly the same. Let's say that they're both 5 inches, whatever, we'll just make them inches. If they're both 5 inches, since these two segments have the same exact length, then by definition, they are what we call congruent segments. And the symbol for congruent looks like this. It's an equal sign, which equals means same size. And this symbol, the old Spanish sign, the old Spanish tilde, that sign right there means same shape. So together, this symbol means same size, same shape. It is the congruent symbol. I also affectionately call it the Spanish equal sign, but whatever. So the congruent symbol means that this guy is congruent to that guy. Here's how you'd write it. You write segment AB is congruent to segment CD, just like that. So your statement that is true is that these two segments are congruent in length. By the way, another way that you'll see this is they'll use tick marks. Let me change color. They'll use what they call tick marks. No, they're not mad. Tick marks are little things that if you don't even know that this 5 inches is there or that 5 inches is there, they'll put little marks on there, and if the marks are exactly the same, that means to you that the segments have the same length. You might not know the length, but you know that they're exactly congruent. Now, if you put a second tick mark there, and there's only one tick mark over there, ladies and gentlemen, those are completely different tick marks. That means that they are not congruent. They don't have the same length. So that is congruent segments. Let's roll into what congruent angles are. Let me move this up. So congruent angles, by definition, are angles that have the same measure. So if I'm going to draw an angle, we'll make it an obtuse angle like such. We'll label it angle A, B, C, D, A, B, C. And we'll say this angle, I don't know, is 140 degrees. Just making it up. Beautiful. So if that angle is 140 degrees, and then I make another angle over here like such, that's D, E, F. Forgive the writing, get used to it. I'm writing with the mouse. And if I want these two angles to be congruent, which means they have to have the same measure, that means if I took my protractor and measured this, this thing better be exactly 144 or 140. If it's just a little off, ladies and gentlemen, they don't have the same measure. Notice it doesn't say they kind of have the same measure. They look like they're alike. No, they have to be exactly the same measure. So if that's the case, then you would say angle A, B, C is congruent. There's your symbol again, same thing for angles. Congruent to angle D, E, F. So there is your statement of truth, because this angle is 140 and that angle is 140. Oh, by the way, same thing applies. If there's a tick mark and the tick marks look like this, they have little symbols on like that, maybe you don't even know that these two angles are 140. Doesn't matter. If you know the angles are congruent, then that means to you that the angles have exactly the same measure. Now, congruent segments, same length. Congruent angles, same measure. Basically, this symbol right here, congruent, means that they are exactly the same way in every way, shape, or form. Awesome. So here comes your CPQ question. You can see on the screen, it's an A, B, C, D, or E response. The question up here says, if you know for a fact angle ABC is congruent to angle FED. If those two angles you know for a fact are congruent, and you also know angle GBA is 90 degrees, the question is asking you, oh baby, what is the measure of angle GBC? Here's G, there's B, and over there is C. So the question is asking you, what in the world is the measure of that particular angle? Is it 32? Is it 58? Is it 68? Is it 90? Or are you saying, hey, Motter, we need more information? I'm excited to see what you put. Have an awesome weekend. Have an awesome Labor Day. And I will see you guys back in school. Later.